Well, all right, everybody. DP and I are going to go visit Terra Drive Systems. Let me tell you, this place is very vertically integrated, very driven by quality. Terra Drive Systems is home, as you can see there in the picture, of Mud Hog and Easy Track. Products and services, the first one being Easy Track. They are producing here are steerable hydraulic axles. You can see that pictured there. The way that they make these products is out of this world in my mind as to how vertically integrated they are with what it is that they are manufacturing. The other product is Mud Hog. As you can see here, that is a tracked system. And then they also have some axles for grain carts. The capabilities that they have are fully integrated designs, sub-assemblies, and then obviously, as mentioned earlier, fabrication. Let's take a step off the website and a step into this plant. I think you will be thoroughly amazed. So we're here in the testing area. Care to explain, sir?
Yeah, so what we have here is a test bed. So it's a large, thick piece of steel that we can do our structural testing so that we can take designs, bring them in-house. We don't have to go out into the field. We can accelerate our testing. And what we've designed is a test bed that can do full axles, but as you can see, there's other components, so we can test smaller structural parts as well.
And when you say what you have designed, you guys designed this test platform and built it all in-house to test your own products and others to find failures, if any.
Correct. Well, we want to make sure that we find them here, if there are going to be any, because you're always pushing the limits in an engineering standpoint. You got to make things better, faster, stronger, and always at lower cost.
And if it ain't broke, break it, make it better.
Someone's going to break it, so we got to find out who's going to do it and what's going to do it.
So help us understand. I see that there is some air. I see that there is some air suspension here.
Yes. Yep.
What does this do, this being your guys' cast housing and your actual component being put under stress?
Yep. So this is a test to simulate cornering on highway trucks. So this is a test on a standard that the Society of Automotive Engineers put out there. So we're testing to their requirements, but it is creating a moment about our hub and our bearings, making sure that you can corner up to 1 million revolutions at a given load through a corner.
And when he says cornering, that's going to apply pressure to this, which is going to apply pressure this way or this way to that assembly.
Yes, correct. Yep.
And then we can take a quick peek over here and we can see that actually broken down into its components.
Yep.
So again, you know, we're going to go take a factory tour, but a lot of this is just me trying to prove the quality that is put in to these units. They test it to try to break it so that the quality that goes out the door, you know, when they say you go out into the field to try to see what happened, they're literally sometimes in a field in the middle of nowhere where you got to have big service trucks to do any work. So why not test it in-house and confirm that if it's going to break, it's going to take something pretty catastrophic?
Yes. Yep. Yep.
So here it is in components.
Yeah, so what we have here, we have the two different sizes. We have our 20 to 24K disc brake hub, and from our analysis, the disc brake was the one that was there's a bit of an area that we want to concentrate on, and so that's what the test is going to show us to prove our FEA. And then we also have our 10 to 20K drum hub, where again, there's a small area in there that we're concerned with, so that's what we're going to test before we get it out in the field.
So since we're going to show them this before we actually see everything in the plant, explain a little bit. This obviously looks similar to that. This looks like a piece that goes up in here. Kind of just give them a quick synopsis.
Yep, correct. So on this back side, we're going to have a bearing, and then we're going to have a seal to keep all of the grease inside the hub to keep your bearings lubricated. So on the back side, it'd be a bearing, a seal, We have our tone ring to pick up on the ABS, so you're not going to affect any of your ABS on your truck. And then as you flip it over, we're going to then again have a bearing placed in here, so you'll have your 2 bearings on your wheel. And then we start to put in the hydraulic components. So we'll have our cam ring that bolts into the system, and this is what the pistons of the motor are going to drive. So as we drive the system, this is what is transmitting the torque from the motor into the hub to drive your wheel. And then you start to put the guts into the system with the motor cover on top of that.
And the guts being this component right here.
Yep. So the distributor is going to say which piston is going to get high pressure and which is going to get low pressure as you're driving through. And then underneath that is the pistons themselves. So we've got porting on one side that takes your high pressure fluid and then engages and sends these pistons out to drive that cam ring.
And if they look back inside this cover here, these actually run on this surface, which is where it starts to communicate hydraulically, if you will, so that it can start to send all that pressure to the proper locations. And then inside the cab, which at the end of this video we're going to do a little trial, inside the cab there is a low speed button and a high speed button. And I know he said some technical terms earlier and I don't remember those, and I'm sure he'll tell us those again, but there was so much pressure. Explain that a little bit.
Yeah.
The 2 settings.
Yep. So all we're doing is changing the pressures of the system. So we have a normal operation where we leave it at our low pressure setting, and that's enough to just get you through normal conditions. You get in some mud, you can get through, and I kind of say it's high, low, 4 high and 4 low.
Okay.
So you're running a 4 high, you really get stuck, you really get in a bad situation, you press the other button, and that's going to give you higher pressure, more effort from your front axle, maximum effort out of the front axle.
Perfect. Well, thank you for the explanation, sir.
Yep.
And when you see somebody build things in their own shop to test their own product, that tells you how much they rely on quality, because it matters. Next up, we're going to go out in the plant and see some stuff being assembled, some sub-assemblies, etc.
I can show you the spindle that makes up of the motor. I mean, the wheel, if you look at that, at this wheel and hub, there's just amount of power. I mean, it is complex because you've got all these hydraulic fittings where you've got drilling through the spindle to go out to a hydraulic motor. And I mean, there's a lot going on. Well, we're going through a redesign right now, because right now this wheel is a 335 and 285, so that's pretty common. You know, in Europe they use 335, and that's what the motor was designed for. But now, if someone puts the axle on, they're going to get all new wheels to get to.
So this is the starting point of the assembly line. All of these components are actually manufactured in-house here, either on the press brakes, the plasma cutter, the welding shop, the CNCs, and then it transfers through each of the next steps to turn into a sub-assembly, to turn into a full assembly. You guys can see all the raw material back in here comes in and starts being processed throughout the manufacturing processes they have in place. Good old bandsaw. Very minimal scrap. You don't see many of these bins sitting around, that's for sure. More of the components in the sub-assemblies prior to the full assembly. Inventory.
But that's the actual axle, and you can see the spindles and hubs.
The schematic of the John Deere axle.
analysis with a paper.
We do have TV screens at all the things.
Lots of components, heavy duty stuff. In-house welding. That's a big axle. How many hours of welding is on that axle?
It's about 40 hours for this product.
For
I mean,
one
you can
axle?
You can see we got 4 guys going.
Yep.
They run all the
We're machining the C-frame. It's a Toyota FA1050, so we can get full axle in there and machine it if we need. But we run a bunch of different stuff on here.
Right.
We machine all of our own valves, steering arms, and then we do assembly for the wheel motor here too.
Hey, Jerry, what are you doing letting him do this price vengeance we got here? What do you
You guys can see the valve bodies in there. How we doing, gentlemen? Not too bad. We've got 1, 2, 3, 4 centers maybe on the far end there. Again, this is pre-assembly. It's always interesting to see these processes. Got one over here running. See if we can see the actual part. Oh yeah, let's get up in there and take a gander. How we doing, sir?
All right.
We're gonna take a gander inside the viewing window here. Lots of fluid. You guys can see the part right there below my finger. The fluid's to keep it cool, while the tool is over here actually performing its job. Thank you for letting us invade your space. And this is what you're producing, correct?
Yeah, those right down there is the end product.
This is the end product for this part of the process.
It's got machined on the top, machined on the bottom, and the bore.
So it goes in as a decent sized chunk of steel and comes out with all these specifics.
And then all this and the board.
Awesome. Thank you, sir.
Yep.
All right, we're 3 seconds in. Go ahead.
So Matt, all of our kits, we've got a template that we lay out, and Lynn will put it on his card and pick every part and lay it on the template. So you can see all these templates are tied to a certain axle number that we provide and our kit part number.
List out all the actual part numbers and the product name.
Yep. And our part number for the entire kit.
So he'll throw this up on the table, and he has to put each of those components over top of the actual picture, and he can visually see and then take a picture to confirm to the customer you did not have missing parts.
And each of those photos are tied to the axle serial number for each product we send out of here. You can see on the card over here.
Talk about a tracking system.
Yeah. You can see over here Lynn's in the process of picking a kit, and each one of these are sitting on their place all the way down to zip ties. So we know exactly how many zip ties are going in to the kit. And then we take the picture right here, and then it's loaded into.
So are we supposed to give him crap since that's not turned the right way?
My God.
Are you that particular, Ben?
We're not that damn particular, man.
No, that's awesome.
I've seen you put shingles on.
Yeah, you're right. Yes. That's awesome.
You also see Ben come off a roof the way the safety man would not approve of. I was worried about that. Yeah, we don't need
Hey, you started it.
I know. So,
that's awesome.
This has helped, one, just helped our kit pickers, making sure they've got everything they need, but also it really assured up our documentation for people who claim they were missing something.
I've ordered other kits, and there's nothing more aggravating than getting a kit and some of the hardware right there. I mean, then you got to call, and you got to wait another 2 days.
Then you got a next day errand.
Yeah.
I mean, it's just not worth it to have to fix it. Just
Agreed.
right up front. Especially when we're sending these all over the world.
Yeah.
You know, they're sending them to Russia, and Europe, etc. It gets pretty costly and frustrating. This one's going over to Vacanzi, Italy for AGCO. And what it's saying is it's down there, but this pin will slide in there and the motor's not.
Do you manufacture so many AGCO, then so many flagship, or?
We do it by batches. Usually, especially international, they'll want to fill a container. So you put 12 of those in a container. So, you know, this week we'll do 12 AGCO and the others, but we'll do them in batches. It's easier to do that too. You can run machine in batches, you can do assembly in batches. Here we're making hose over there.
You make all your own hoses in-house.
We do. We buy the hose, we buy the fittings, we cut it, we crimp it. That is a hose machine.
Yeah, that's a hose machine. That's way quieter than the hose machine I'm used to standing around when they cut it.
Safer pollen?
Yeah.
Look at every point of the hose.
Yes, lots of hose.
PVC pipes to run it through to keep it.
Yep.
All right, you ready now, man?
I'm ready.
So this is the end of our assembly line. All of our axles are 100% tested. Lauren's just finishing up a test. So we hook it up to our test stand, test functionality, make sure there's no leaks. But 100% of our axles are tested after assembly. On the other side of the test stand, we test our valves, because 100% of those as well. And then we also sample wheel drives and test the motors.
So every single axle that leaves this building has been tested. Forward, reverse, and leak tested.
Correct. Lauren does it. Oh, Lauren, did I miss anything? Would you add anything? This is my cousin. Not this one. Yeah, not that one.
That's everything to go through here.
Yeah. So these are our valves. Again, we assemble them over here in a white room, put them up to test, 100% tested.
Now, not everybody in this world understands what a white room is. You assemble it in a white room because of cleanliness.
That's right.
You can't have any debris inside of that, or that debris could fault the system out.
Correct. It could lead to a catastrophic failure of the hydrostatic system on the compound. Not just our product, but the whole hydrostatic system.
Right, because this is also going to tie into the factory hydraulic system, and you don't want to contaminate that system. So cleanliness is key.
Well, we also thermodeburr all these as well to make sure there's no shavings after machining.
Awesome.
So, anyways, we can
take all the proper steps. Something. What were you hollering?
I said, first off, I'm as impressed with their test equipment as I am their product.
Absolutely.
It's incredible the effort they go through to make sure it leaves here.
Quality,
But
quality,
You
quality.
just told me the reason why this machine is so reliable and so precise in the test is because of the operating system.
It's been around for a long time.
Huh. Do share.
No more sharing. It's the DOS system.
Oh.
Hey, if it's not broke, don't fix it, right?
Yeah. Oh, I don't know if that's the right comment, but that's a valued phrase. So this is the 100% completed, tested, ready to go out the door axle. All right, so walk us through the steps, sir, before Michael tries to tear your truck up.
Hey, he said product testing. I said, I'm your guy.
So the system's fully automatic. While you're in drive or reverse, you can turn the system on and off with the easy track button here. You just hit the button, system automatically turns on. Now it will only work in first gear. We are speed limited up to 12 to 15 mile an hour depending on what transmission options you have. So for this hill, we'll go
I'll
up.
set the stage right here. We're creating a scenario, so somebody's going to call me, you can just lock in your power dividers, you can get up there. Yes, you can, but there's going to be scenarios where that don't work and you still need something extra. So we're going to drive up to the hill, we're going to spin out, we're going to hit that button, we're going to climb the hill.
And you're not going to let off your throttle, right? You're going to hit that button while the tires are spinning?
Ask him to put his ear in.
Yeah, I'm not hearing any of this.
Hey, product testing. We're going, I mean, if we need warranty, it's like 100 feet that way.
So let's lock her in first there.
And Ben's not in the truck, so we're good.
Lock her in first. I need to be in manual.
So drive.
Which you would do
And hold
anyway
in.
if you're going off the road.
And then drop down once. Yep.
You ready?
We're ready.
I'm just going to gut it. We're going to spin out.
All right, we're spinning out.
Hit the button. You ready?
Yep, go for it. We hit the button,
We're going places again.
and just like that.
That's the first setting.
Yeah, that's low power setting, not high power setting.
So that's
This is
limited
the-
to about
this is-
150 bar of pressure. You've got mode switch, which will run you up to 300 bar of pressure.
This is the funnest part. Hang on, we're going backwards. That's not reverse. That is reverse. Truck, I want to go that way. Neutral. I gotta get here.
So now this is just operator error, just so everybody
Well,
knows.
this is a failure to communicate between me and the truck. We need one of that.
Yes, we do. Now let me hop out and
We
get him a
just-
view from
we
the
just
outside.
need the owner of this operation.
Ah! Daggone alarms on these new trucks. All right, so again, this system is on the front tires. When he pulls up, yes, you can lock everything together, but this is to product test it to show you that when that spins, those tires are going to take off and pull everything up over the hill. Spinning out. That's awesome. You guys can see the oil cooler there. And the actual pump is mounted where you see those new hydraulic lines coming down. So it's mounted right in there next to the actual, well, here it goes backwards. It's mounted in there off of the frame rail.